space launch is the earliest part of a flight that reaches space. Space launch involves liftoff, when a rocket or other space launch vehicle leaves the ground, floating ship or midair aircraft at the start of a flight. Liftoff is of two main types: rocket launch and non-rocket space launch. Issues with reaching space. Definition of space. Space has no physical edge to it as the atmospheric pressure gradually reduces with altitude. Instead, the edge of space is defined by convention, often the Kármán line of 100 kilometers. Other definitions have been created as well. In the US, for example, space has been defined as 50 miles. Energy. Therefore, by definition, for spaceflight to occur, sufficient altitude is necessary. This implies a minimum gravitational potential energy needs to be overcome. For the Kármán line, this is approximately 1 megajoule per kilogram. W equals mgh, m equals 1 kilogram, g equals 9.82 meters per square second, h equals 105 meters. W equals 1 asterisk 9.82 asterisk 105 106 J per kilogram equals 1 megajoule per kilogram. In practice, a higher energy than this is needed to be expended due to losses such as air drag, propulsive efficiency, cycle efficiency of engines that are employed, and gravity drag. What we have in the past 50 years usually meant, though, by spaceflight has included remaining in space for a period of time, rather than going up and immediately falling back to Earth. This entails orbit, which is, at altitudes prevalently entered by such means, not a matter of altitude, but rather of velocity, which is not to say that we need not discuss air friction and relevant altitudes in relation to that in orbit. At much higher altitudes than many orbital ones maintained by satellites, altitude begins to become a larger and larger factor and speed a lesser one. At lower altitudes, due to the high speed required to remain in orbit, air friction is a very important consideration affecting satellites, much more than in the popular image of space. At even lower altitudes, balloons, with no forward velocity, can serve many of the roles satellites play. G-forces. Many cargos, particularly humans, have a limiting G-force that they can survive. For humans, this is about 3 to 6 grams. Some launches, such as gun launches, would give accelerations in the hundreds or thousands of G and thus are completely unsuitable. Reliability. Launches vary with respect to their reliability for achieving the mission. Safety. Safety is the probability of causing injury or loss of life. Unreliable launches are not necessarily unsafe, whereas reliable launches are usually, but not invariably, safe. Apart from catastrophic failure of the launch vehicle itself, other safety hazards include depressurization, and the Van Allen radiation belts, which preclude orbits which spend long periods within them. Trajectory optimization. Trajectory optimization is the process of designing a trajectory that minimizes or maximizes some measure of performance within prescribed constraint boundaries. While not exactly the same, the goal of solving a trajectory optimization problem is essentially the same as solving an optimal control problem. This problem was first studied by Robert H. Goddard and is also known as the Goddard problem. The selection of flight profiles that yield the greatest performance plays a substantial role in the preliminary design of flight vehicles, since the use of ad hoc profile or control policies to evaluate competing configurations may inappropriately penalize the performance of one configuration over another. Thus, to guarantee the selection of the best vehicle design, it is important to optimize the profile and control policy for each configuration early in the design process. Consider this example. For tactical missiles, the flight profiles are determined by the thrust and load factor histories. These histories can be controlled by a number of means, including such techniques as using an angle of attack command history or an altitude downrange schedule that the missile must follow. Each combination of missile design factors, desired missile performance, and system constraints results in a new set of optimal control parameters. Sustained spaceflight. Suborbital launch. Suborbital spaceflight is any space launch that reaches space without doing a full orbit around the planet, and requires a maximum speed of around 1 km per second just to reach space, and up to 7 km per second for longer distance such as an intercontinental spaceflight. An example of a suborbital flight would be a ballistic missile, or future tourist flights such as Virgin Galactic, or an intercontinental transport flight like Spaceliner. Any space launch without an orbit optimization correction to achieve a stable orbit will result in a suborbital spaceflight, unless there is sufficient thrust to leave orbit completely. Orbital launch. In addition, if orbit is required, then a much greater amount of energy must be generated in order to give the craft some sideways speed. The speed that must be achieved depends on the altitude of the orbit. Less speed is needed at high altitude. However, after allowing for the extra potential energy of being at higher altitudes, overall more energy is used reaching higher orbits than lower ones. The speed needed to maintain in orbit near the Earth's surface corresponds to a sideways speed of about 7.8 km per second, an energy of about 30 megajoules per kilogram. This is several times the energy per kilogram of practical rocket propellant mixes. Gaining the kinetic energy is awkward as the air drag tends to slow the spacecraft. So rocket-powered spacecraft generally fly a compromised trajectory that leaves the thickest part of the atmosphere very early on, and then fly on, for example, a home and transfer orbit to reach the particular orbit that is required. This minimizes the air drag as well as minimizing the time that the vehicle spends holding itself up. Air drag is a significant issue with essentially all proposed and current launch systems, although usually less so than the difficulty of obtaining enough kinetic energy to simply reach orbit at all. Escape velocity. If the Earth's gravity is to be overcome entirely, then sufficient energy must be obtained by a spacecraft to exceed the depth of the gravity potential energy well. Once this has occurred, provided the energy is not lost in any non-conservative way, then the vehicle will leave the influence of the Earth. The depth of the potential well depends on the vehicle's position, and the energy depends on the vehicle's speed. If the kinetic energy exceeds the potential energy, then escape occurs. At the Earth's surface this occurs at a speed of 11.2 km per second, but in practice a much higher speed would be needed due to air drag. Types of space launch. Rocket launch. Rocket launch is the only current way to reach space. In some cases an air-breathing first stage has been used as well. Non-rocket launch. Non-rocket space launch is a launch into space where some or all of the needed speed and altitude are provided by something other than expendable rockets. A number of alternatives to expendable rockets have been proposed. In some systems such as skyhooks, rocket sled launch, and air launch, a rocket is used to reach orbit, but it is only part of the system.